So section 4.3 will study the inverse of a square matrix. راح نشتغل فقط على square matrix. معناها the number of rows هو equal number of columns. Order m by m. Square matrix. So the inverse. Let's see, we introduce inverse and we'll see how to compute the inverse of a matrix وليش نحتاجه. Let's start. Before defining the inverse matrix, we need to introduce a special matrix called the identity matrix. The identity. شو هذه؟ So the identity matrix is a square matrix, order n rows and columns. شو عندها؟ عندها 1, all the elements on the diagonal I equals 1 كله. هذم diagonal elements. And all other elements are 0. 0 when I is different from J. معناها this is identity of order 2, I2, 1 on the main diagonal, and the other elements are 0. The identity of order 3, 1 on the main diagonal, and all other elements are 0. The identity of order 4, 4 rows, 4 columns, 1 on the main diagonal, and other elements are 0. هذه اسمها identity. A11, A22, A33, A44. All elements on the diagonal equals 1. All other elements equals 0. اسمها identity. والعدد هنا هو يعطيك order. How many rows and how many columns in this identity matrix. If we multiply a matrix by the identity, any matrix multiplied by the identity to the left or to the right, تعطينا the matrix itself. Then the identity تلعب دور ال1 for the multiplication of scalars. نعرفه for any scalar x تضربها في 1 تعطيك x. 5 times 1 5. 1 times 7 7. هذا for scalars. So the identity for multiplication of scalars is 1. The identity for multiplication of matrices is in. Okay? هنا بالطبع حتى نكون قادرين انه we multiply لازم the order matches. Okay? لازم the order matches. So لازم the number of columns of I here equal the number of rows of A, and here number of columns of A لازم equals the number of rows of I. Then when the multiplication is possible, is defined, multiplying any matrix by the identity to the left or to the right, تعطينا the matrix itself. هذه هي identity for the multiplication of matrices. We can see an example. So if we take this matrix A of order 2 by 3, if we multiply it by the identity of order 2, so the multiplier, the product is defined. So this is the identity of order 2, 1 on the diagonal, 0 elsewhere. We multiply it by this matrix. تعطيني matrix هذه 2 by 2, هذه 2 by 3. تعطيني matrix 2 by 3. Then 2 rows 3 columns. The first element تاخذ the first row by the first column. إذا نضرب 1 في 2. So R1 C1 1 في 2 plus 0 في negative 3 تعطيني 2. R1 C2 تاخذ first row second column. First row second column 1 في 4 plus 0 في 7 تعطيني 4. نفس الشيء first row third column 1 في 0 0 0 في negative 1 0 this is 0. هذا row 2 column 1. So row 2 column 1 0 times 2 plus 1 times negative 3. Negative 3. Okay? And you can check that here you obtain 7 and here minus 1. So what is the result of the product of the identity matrix of order 2 by the matrix A? إذا نقارن النتيجة ب A شو تلاحظوا؟ The same matrix. It's exactly A. So multiplying by the identity, take the same matrix. اتفقنا؟ This is the identity matrix for the multiplication of matrices. This is calculation and this is the result. If you multiply by identity, no need to make the calculation. It's known that multiplying a matrix A by the identity, take the same matrix. Same thing here. You can try identity times A to the left, to the right. This gives you A. This gives you also. Okay, so this is the identity matrix. If a matrix is square of order A, the inverse matrix denoted by A inverse. This is the inverse matrix of A. A to the power negative 1, the inverse matrix. If it exists, it's not always defined. When it is defined, must satisfy the following rule. لازم, if we multiply A by its inverse to the left and to the right, we must try both sides. لأنه قلنا multiplication, remember, multiplication of matrices is not commutative. شو معناه؟ معناها usually A times B is different from B times A. Okay, so you need to check both sides. When the product of A by this matrix to the left and to the right gives you the identity matrix, we say that A is invertible or non-singular. Non-singular means it has an inverse. It has an inverse. Such a matrix exists. We say invertible or non-singular. Otherwise, we say it is singular. Singular means does not have an inverse. Does not have an inverse. Okay, this is the definition of the inverse of a matrix. And this is valid only for square matrices. إذا الماتريكس is not square أصلا ما نحكي على inverse. We deal with inverse matrices only for square matrices. Okay? And of course, not all square matrices have inverses. So a square matrix can have an inverse, and some of them are singular. They don't have an inverse. The inverse of the identity is the identity. Okay? Then, and the first case when we have a candidate. يقول لي verify, check that this matrix is non-singular, it has an inverse, and he proposed the candidate. يقول لي, and its inverse is this matrix B. In this case, what we have to do, we have to check. Check what? Check that if we multiply A by B, we get the identity of order 2 here, because A is of order 2. And so both sides, we check that B times A equals the identity of order 2. If these two are fulfilled, then نقولوا B is the inverse of A. إذا لازم نحسب A times B. نحسب A times B. A is -1, 2, 3. B -3, -1, 2, 1. And the result will be a matrix of order 2, 2. سؤال هل النتيجة هي identity؟ Another -1 في -3. 3 plus -1 في 2 -2 إذا تعطيني 1. -1 في 2 و2 في 1 تعطيني 0. -1 في -3 3 plus -1 في 3 0. -1 في 2 -2 plus 3 times 1 3 تعطيني. So yes, this is satisfied. نمشي للحين the other side. B times A. -3, 2, -1. 1 times A, 2, 3. السؤال هل the result هل هو أيضا the identity؟ إذا تحسب هذا you use first row first column. -3 في -1 3 -2 إذا 1. -3 في 2 -6 plus 6 0. -1 في -1 1 -1 0. -2 plus 3 1. Yes, it is satisfied. So A is non-singular and A inverse is B. So this is the inverse of the matrix A. So we checked that this is the good candidate and we recruit him as the inverse of the matrix A. Okay, then هنا لما يكون عندنا candidate and we just check that this candidate fulfill all our requirements. هل يحقق شروطنا حتى نتعاقد معاه ك inverse of. So this is what we have to do. Just show that AB and BA both are equal to the identity of order 2. So multiply and check. Same here, verify that the inverse of A is B. Same thing. لازم you calculate AB, you calculate BA both. لازم في الأخير هذه identity وهذه identity. Okay? Then AB 1 minus 1, 2, 3 times 3 over 5, 1 over 5 minus 2 over 5, 1 over 5. وBA ناخذ in the order. then تضربه في 1 minus 1, 2, 3. And لازم both results لازم يعطيني the identity. then هذا تضرب 1, so row 1 column 1 راح يكون 1 times 1 over 5, 3 over 5 plus 2 times 1 over 5. شاتيني 3 over 5 plus 2 over 5, 5 over 5, so 1. then هذا R1 C2. إذا تضرب 1 في minus 2 over 5 plus 2 في 1 over 5. يعطيني minus 2 over 5 plus 2 over 5 يعطيني 0. وممكن تكملوا هذا 0 هذا 1. So yes. هذه نفس الشيء إذا تحسبها تعطيك 1 0 0 1. So yes. So B is the inverse of A. And A is invertible or non-singular. لأن هذا لما يكون عندي متقدم مترشح يقول لي verify that A has an inverse and this inverse is this matrix. Imagine that now يعطيني only A ويقول لي تصرف. Calculate the inverse of ما يعطيني candidate ما يعطيني مقترحات. إذن في الحالة هذه شو أسوي؟ لازمني قوانين نشوف بها أحسب بها the inverse. إذا our matrix is of order 2, we have a quite easy formula. This is the formula for the inverse. It's AD minus BC. AD minus BC شفناها هذه. شو تمثل AD minus BC؟ مين يتذكر؟
Determinant.
هي the determinant of A. Then 1 over the determinant of A, or 1 over AD minus BC. Times what? لأن هنا شوفوا اللي بالأحمر A و D غيرنا لهم مكانهم. A و D غيرنا لهم مكانهم. والبي والسي خلينا لهم مكانهم لكن غيرنا لهم إشارات. So it's very easy for a matrix of order 2 to calculate the inverse matrix. هنا شوفوا مثال. Find the inverse of this matrix A. The inverse راح يكون 1 over what? لازمنا نحسب determinant of A. كم determinant of A? AD minus BC. إذا 1 times 8 minus 3 times 2. كم هذا؟ 8 ناقص 6 2. Then 1 over 2 multiplied by the matrix. Which matrix? هذم يغيروا أماكنهم. تصير 8 هنا 1 هنا. وهذم يغيروا إشاراتهم. تصير minus 3 و minus 2. And this is the, it's not A of course, it's A inverse. بعدين you multiply by half for minus 3 over 2 minus 1 half This is the inverse matrix of اتفقنا? This is how to calculate the inverse of a matrix of order 2. نعيدها. نطبق القانون. هذا مغيروا أماكنهم. هذا مغيروا إشارات. This is the inverse matrix. نرجع الملاحظة اللي سويناها في أول السكشن. قلنا not all square matrices has an inverse. ليش حسب رأيكم؟ متى يكون عندي مشكلة؟ متى تكون ماتريكس ما عندها inverse من الفورمولا هنا؟ ممكن نعرف وين المشكلة اللي ممكن تواجهني هنا؟
إذا كان صفر.
ليش؟ لأنه عندي قسمة، وش قلنا؟ ممنوع القسمة على صفر، إذا عندي شرط. لازم هذه different from zero. إذا هذه zero مش راح أعرف أحسب الإنفرس أصلاً. The inverse does not exist. إذا كيف نعرف إنه ماتريكس عندها inverse أو لا؟ لازم هذه different of zero. وقلنا هذه هي determinant. إذا ليش سميناها determinant? Because it determines whether a matrix has an inverse or not. واضح؟ So if determinant of A 0 نقول A is singular. If determinant of A not 0, A is invertible or non-singular. Or A minus 1 exists. Okay? إذا قبل ما تحسب الانفرس، قبل ما تبدأ تحسب لازم تحسب determinant of A، تشوفوا 0 or not 0. إذا 0 singular، إذا not 0 invertible، وتطبق القانون حتى تحسب الانفرس. Okay? So find the inverse of its matrix if it is possible. To know whether it's possible or not لازم نحسب determinant of A. إذا هذه كم determinant of A؟ minus 1 في minus 2 minus 2 في 2. So it's 2 minus 4 so negative 2. إذا هنا هل عندنا inverse or not؟ A هل هي singular ولا invertible؟ So since it's not different from 0, so the inverse exists, and we calculate it. How? It's 1 over determinant of A, and here we switch the positions, and here we switch the signs. It's 1 over negative 2. Minus 2, minus 2, minus 2, minus 1. We multiply by negative 2, 1, 1, 1. This is the inverse of. What about B? For B, we calculate the determinant of B. So 6 times 10 minus 5 times minus 12, 60 minus 60 is 0, and this means that B is singular. But B inverse doesn't exist. For C, we calculate the determinant of C. So what is the determinant of C? It's 1 times x squared. So x squared minus 1 في 2 minus 2. Then minus 2 يعني plus 2. شو رايكم في الديترميننت هذا؟ هل ممكن يكون 0 x سكوير بلس 2؟ متى x سكوير بلس 2 is 0؟
نحل المعادلة يا دكتور ولا ما؟
اي حل x سكوير بلس 2 equals 0. حل المعادلة. متى؟
جذر
ما
اثنين.
في ما في لا
ما
دائرة
في.
التجربة.
It's هذه always different from 0 always. لأنه x سكوير positive وتزيدها 2 so different from 0 always. So C is non-singular always. ما تجي square root of 2 لأنه لما تحل معادلة تمشي هذه x square is minus 2 no real solution. Okay, so here C have an inverse, it is non-singular, we have no problem. C non-singular. And C inverse exists. Okay, what is C inverse? So it will be 1 over the determinant, 1 over x squared plus a times here you change position x1, here you change signs 1 minus 2. So finally C inverse, if you want, here x over x squared plus 1 plus 2, 1 over x squared plus 2 and so on. قسم كل ال elements على x squared plus 2 and you get the inverse. Is it clear? This is how to obtain the inverse of a matrix of order 2. Okay, what happens when matrix is of a higher order? So we have also a procedure to calculate the inverse matrix of order, of any order, of course. It's important. So first step, كما شفنا في order 2 لازم نشوف determinant 0 or non-zero. إذا 0, the matrix is singular and the inverse does not exist, and we stop. If the determinant is not 0, the matrix is invertible, and we proceed to step 2. In step 2, we construct what we call the co-matrix of the matrix A, denoted by COM, com of A. شو هذه؟ هذه فيها the matrix of cofactors اللي شفناهم في determinant before. Then we transpose it and we multiply it by 1 over the determinant of A. Okay, so if determinant of A is non-zero, A inverse exists, نحسب the co-matrix and we multiply it by 1 over the determinant of A. This is the procedure to calculate the inverse of a matrix of any order higher than 2. شوف مثال. This is the matrix A. So first step, calculate determinant of A. لأنه هو اللي يقول لي A has an inverse or not. وفي كل الحالات بعدين I need it in the formula. لأن كيف نحسب determinant of A? This is a matrix of order 3. نحسب Sarius for example. شو يقول Sarius؟ يقول I repeat the first column and the second column and I multiply the diagonal in this way. So determinant of A will be 7 times 3 times -2 plus 2 times -1 times -3 plus 1 times 0 times 1. بس لا نمشي other side. We multiply the diagonal in this way with a minus. Then 2 times 0 times -2 plus 7 times -1 times 4 plus 1 times 3 times -3. إذا تعطيني الأولى نحسبها بالكالكوليتر أو mentally 0 minus 0 minus 28 minus 9 وتحسب minus 36 plus 37 equals 4. So the determinant is not 0. So A is invertible. إذن هنا لازم نقدر نحسب A inverse. القانون شو يقول لي؟ يقول لي A inverse is one of determinant of A co-matrix of A transpose. إذن هذا عندي determinant of A. أوكي باقي لي هذه co-matrix of A. كيف أحسبها هذه؟ co-matrix of A هي راح تكون C11 C12 C13 C21 C22 C23 C31 C32 C33 والسي هذم هم الكوفاكتورز. باش ناخذ one example اخرين ترجعوا لل section 2. So to calculate C23 مثلا we start by calculate the minor M23. It's the determinant of a matrix obtained by 2, 3. So you remove the second row and the third column. What are the remaining elements? 7, 2, minus 3, 4. You calculate this determinant, 28 plus 6, 34. So C23, and 2 plus 3 is odd, 5. إذن هي minus M23 minus 34. So this element equals minus 34. And so on. You calculate all these 9 cofactors. So this is what you do. This is the minor matrices obtained by removing the corresponding row and column in each case, and this signs the position the C11 1 plus 1 even plus 1 2 odd 1 3 1 plus 3 even plus minus and so on. So you get this cofactor, the matrix of cofactors, the comatrix. You have 9 determinant to calculate. You obtain the comatrix. Once you obtain the comatrix, خلاص, this is the difficulty. هنا طويلة شوية, لكن the inverse قلنا عندنا the formula 1 over determinant of A comatrix of A transpose. So here we are done. So A inverse determinant شو لقيناه؟ determinant قلنا 1. So here 1 over 1. And the transpose ايش قلنا the transpose قلنا the first row تولي تصير the first column -2 3. The second row of the matrix when we transpose here the second column. So 8 minus 11 minus 34. The third row of A here, third column of the transpose. So -5, 7, 20. And we are done. This is the matrix. Then تحسب determinant. You calculate the 9 cofactors. You construct the comatrix. You write its transpose. You multiply by 1 over the determinant, and you get the inverse. Okay, this is how it works for higher order matrices. Any question?
هذه تجي في الاختبارات عادة يا دكتور.
Order 3 طويلة شوية ما أتوقع. معناها باش يقول لك في الاختبار الفاينل احسب لي the inverse of matrix of order 3. I don't expect, but ممكن بما أنه درستها. So it's possible لكن order 2 yes. Check whether a matrix has an inverse. Definitely yes. But order 3 صعبة شوي. اوكي لانه تاخذ وقت طويل هذه المشكله هي فيزبل ما فيها شيء هذه هي الاجابه بصراحه هذا شرحنا في section 4.3 how to calculate the inverse of a matrix of order 2 and of a matrix of higher order 2 quick and easy higher order أطول شوية لأنه قلنا تبدأ تحسب determinant of A تستخدم ساروس. So تحسب 1 في 1 في -2 plus 2 في -1 في -1 2 plus هذا في هذا 0 minus تفتح قوس 2 في 0 في negative 2 0 plus 1 في -1 في 0 0 plus -1 في -1 وانت تعطيني -3 different from 0 so you continue. Okay, تحسب the comatrix of A اللي هي هنا 9 cofactors. تحسبهم ضمن. اوكي اذا حتى تحسبهم تحسب الماينرز. So determinant تشيل first row first column 1 -1 0 -2 تعطيني -2 وتحسب بها C11 اللي هي نفس M11 -2. بعدين تحسب الماينر of 1 2. Then you remove first row second column. تبقى 0 -1 -1 -2 0 -1 يعني -1 وتحسب الكوفاكتور C12 1 plus 2 odd minus M12 then وتكمل الباقي جيك الكوماتريكس بعدين تحسب الترانسبوز بعدين الانفرس 1 of the determinant of A transpose of the comatrix. This is the formula for a matrix of order higher than 2. So this is section 3. Any question?